a troubleshooting lab. So here is our topology. Okay, we have R1, R2, R3, and R4. Right, R1 and R2 are connected with eBGP. R3 and R4 are connected with eBGP, but R2 and R3 have an IBGP session connected with them. Okay, R1 you can see is in 65001 AS, R4 is in 65003 AS, and R2 and R3 are in 1 AS 65002. Right. So this is my addressing schema, right? Um, this is all the links which we have, right? On R1, I have a loopback configured, and on R4, I have a loopback configured, right? Which I have then advertised through R3, right? In the BGP. And um, yeah, this is what I've mentioned, right? R2 and R3 are a transit, correct? As per this diagram. Now, what's the problem statement? The problem statement is a customer connected to AS 65001 has opened a ticket against the transit provider stating that they cannot reach a partner hosted in R4, right? So from R1, we are trying to reach to R1, but somehow we are not able to reach, right? So what does reachability mean from our perspective is if we ping either from R1 side or R4 side to each other's loopback, they should be able to ping each other, right? They should be reachable to each other. Then we have a end-to-end connectivity, at least from our topology and the the setup which we have from that point of view. Okay, so let's bring up the lab, right? This lab is built in container lab. Okay, so I'll go ahead and connect with my router one, and I'll just show you the configuration, right? So this is a very basic generic configuration. Okay, this is an FRR. The OS on this device is FRR, right? So the generic configuration, right? All the interface configurations, correct? The loopback configurations, all the router BGP configurations, right? Same is there on R3, R2, R3, R4, right? Now, if we check the problem statement, it says that from R4 we should be able to ping R1, and from R1 we should be able to ping to R4, right? So I'm currently on R1, right? And let me try to ping R4's IP address, right? It is not working, correct? So first, um, let me check if the BGP sessions are formed, right? And we can clearly see here, right, that the session is in established state, right? And we have uh, we have connectivity with our neighbor, that is R2, right? Which we are seeing that it is in say 65002, right? And it is up from this much amount of time. So from our perspective, right, it is this BGP sessions are formed, right? Let me validate it on some other R2 as well, right? So show IPBGP summary. See, I have from R2's perspective, I have two um, uh, sessions, right? BGP sessions, one on A65001, right? Another on 65002, correct? Let me check on R3. On RP also, I have, two BGP sessions, right? On R4, even on R4, I have two BGP session, right? So all the BGP sessions are configured, right? If I check on um, R4's configuration, right? See, the configuration is fairly simple, right? There is no policy which is preventing the route from, being inserted in a routing table, right? Or there is no policy as such on R3 or R2 or R1, right? Which is preventing the routes to be, shared with the other routers, right? The configuration itself is very simple, right? So um, from configuration wise, right, everything looks perfectly well. Okay, there is no issue with the configuration, right? Now let's see the what all routes are we receiving on routes received, right, from, and on R3 I'm seeing um, two routes, right? One which I am getting from 10.1.1.0, right? So I am in fact getting this route, right, 10.1.1.0 in my routing table, right, from iBGP. You can see it is correct. So BGP is having this route, right? It is having this another route also, right, which it is receiving from 10.4.4.0, right? Let's see on R2 also. BGP before unicast. Here also I'm seeing these two routes, right? I This one route which I'm receiving from iBGP, right? Another route which is I'm receiving from the eBGP, correct? Which is from my the other AS, correct? Now, what's the problem then, right? We don't see any problem with the configuration, right? We are seeing that the routes are present, right, in BGP. So what's the issue? So let's go over BGP in brief, right? Before going further, let's see some basics of BGP. Okay, so we all know that BGP is internet's interdomain routing protocol, right? We have which is basically used to route traffic between two different AS, right? We have a couple of terminologies, correct? Most of us already know this, right? eBGP, what does iBGP mean, correct? So this is the best path selection procedure, right? How a best path is selected from highest weight, then local preference, local originated route, then the shortest AS path, the origin type, MED, right? We prefer eBGP over iBGP, then lowest IGP metric, right? Some basic configuration snippets for eBGP versus IPGP, right? But here is our one important part, right? Next hop self, right? So we know that um, if there is any route which is received from you know eBGP, right, then iBGP will advertise that route to another IGP, whoever it is connected with, correct, to its neighbors, right? But if it is getting a route from another IBGP members don't advertise routes uh, to each other. Okay. So whatever routes are received from eBGP are advertised in iBGP. Whatever routes are received from iBGP are advertised to eBGP, right? But routes received from iBGP are not transmitted or advertised to iBGP. Okay. So one of the concepts we know here that these BGPs devices are in different AS, right? So we have a eBGP session, right, and one iBGP session. So eBGP routes are advertised in iBGP. Okay, but when an iBGP, so we have these two routers which are transmitting routes between with each other, right? So we have route received from R4, right, to R3. When R3 sends, so when R4 advertises to R3, it sends R4 sends uh, itself as a next hop, right? For 10.4.4.4 when it sends to R3, right? When this R3 sends it to R2, right? By default, it does not mark itself as the next hop for this route 10.4.4, right? The way it should work is when R2 receives a packet going towards 10.4.4, it should know that this is the next hop to go to, right? But by default, that is not the behavior when we are transmitting, when we are advertising the routes from one IBGP member to another IBGP member. Okay, so that's where our this logic is broken. Okay, so um, we have a command which we can use, right? So that when we are advertising a route to a particular neighbor, we tag it with ourself as our next stop, right? And then whatever packets are coming to that destination, the next stop will be will be that particular router. Okay, so we are seeing that this configuration is per neighbor basis. Okay, so we can configure it for few neighbors. If we don't want, we can skip it for others. Okay, so let's try doing it on R2 and R3. This will be on R2 and R3. The configuration change. This won't be on R1 and R4, right? Because this is specific to IBGP, how IBGP works. So R2 and R3 are in this IBGP domain, right? So we will have this configuration towards each other. Okay. So let's just see this configuration, right? We are seeing that it is not there, right? There is no next hop self configuration, right? So let me go in conf t, right? I have this configuration already pasted, or just for brevity. Okay, we are in this router BGP 65002, right? I'm going in address family, basically, right? I'm activating the next hop self on the neighbor and I'm exiting. So this is as simple as it can get. Okay. Now let's see the running config, right? Now I have here in this running config, I can see this configuration, right? Let me do the same on R3, right? If we see now, right, we don't have this configuration, right? So let me go in conf t, just same thing, just doing it on the other end, right? Uh, Show running config, right? Um, we can see this configuration, right? So this configuration itself is actually present, right? So yeah, now this you can see, right? If we go above, right? Let me copy paste this we got from R3, right? And what I got earlier from R3 here, right? You will see some differences, right? See this config, right? We are seeing these two snippets of config, right? This is after and this is before, right? So before you can see that this remains same, correct? Because this is the route which is coming from eBGP, right? So there is no change here. But if you see here, right, on R3, correct? R3 was earlier showing this route or this next hop as 10.12.0.1, okay, which is the link between R1 and R2, right? But now this is the next hop after configuring our next hop self, right? This is the link which is on between R2 and R3, right? So now it knows that R2 is my next hop, right? Earlier, this next hop was going to the interface towards R1, right? Which is not there, right? From R3 to R1, there is no connectivity, right? So this next hop does not exist, okay, or is not valid from R3's perspective, right? Therefore, this route was not shared, okay, or advertised to the external party, okay, to R4 basically, okay. Now, if we go back and see, um, let me connect to R3. Okay, I'm already connected. If we see now, uh, so IP, BGP summary, right? I can see that now it's connected, right? And our received prefixes, right? And sent prefixes are both one. Okay, earlier it was the sent prefixes was 0. Okay, so now let's try to do the opposite way. Yeah, this is also working fine as expected. Yeah. So next hop self was the real culprit. And we now understand that, you know, that if there is a route which is coming from eBGP, right, and being redistributed to IBGP, in many scenarios, right, next hop self will be required so that your routing is working